and welcome to this lecture on history and evolution of immersive media. Today, we will continue the lecture journey that we started in the previous lecture. At the end of today's lecture, you will be able to understand the revival of AR/VR after the year 2000. We saw how there was a VR winter after the initial explosion in VR technologies until the 90s. There was a VR winter in the late 90s. Then we will see how this revived after 2000. We will learn about some key industry milestones in this journey after the year 2000. We will explore the emergence of XR and spatial computing. We will also analyze future directions in which XR technology is headed. So, from 2000 till 2010 can be said to be the quiet years of AR/VR. This is also referred to as the VR winter. So, the reason for this VR winter were manifold. One was expensive hardware, another was that graphics capabilities were limited, the third was that software applications were not coming forth as quickly. So, driven by sci-fi and hype, the consumer expectations grew through the 90s into the 2000s. However, the hardware capabilities in terms of depicting polygons on screen, in terms of the latency between the actions of the users and reflecting that in the display screens, and the optics lagged behind. So, you can see that the progress in hardware capabilities was much slower than the pace at which the expectations rose. So, this created a nausea gap where VR systems suffered from motion sickness, high latency, low resolution and commercial failure. The expectations of the consumers were entirely decoupled from silicon realities, that is the developments in chips, developments in hardware were much slower than the expectations at which consumer expectations rose. High latency and poor refresh rates broke the illusion of presence, leading to physical discomfort and the total collapse of consumer VR funding. But still important groundwork continued. What turned out to be the savior of the VR journey was the emergence of the smartphone. The smartphone boom was characterized by high density and low persistence displays which are necessary for these smartphones. So, this solved the screen door effect which was essential for VR systems. It was also characterized by the rise of MEMS gyroscopes and accelerometers that solved the problems of latency and tracking. So, we are able to capture the movements of users much better. This period was also characterized by the development of mobile ARM processors for these smartphones that solved the problem of managing weight and heat simultaneously in a VR headset. So, all of these developments in smartphone supply chains led to what can be said to be the first good VR prototype, which is the Oculus Rift, which came out in 2012. So, the VR winter ended not because of a sudden breakthrough in VR labs, but because the mobile phone industry inadvertently miniaturized and cheapened. So, miniaturized and cheapened the exact components required for immersive headsets. So, the smartphone revolution had a number of key innovations in the form of accelerometers, gyroscopes, newer and much higher spec cameras, GPS systems which were incorporated into smartphones to enable users to be tracked in terms of their location, and also mobile GPUs which enabled faster processing. So, these 5 key innovations were crucial in the smartphone revolution and also translated into the VR journey. So, these served as an unexpected catalyst for XR. These components are exactly what AR/VR systems require. The smartphone industry subsidized the development of XR hardware as well, and the costs came down dramatically. Without smartphones, modern VR may have taken much longer to emerge. So, this led to the next phase of AR/VR development, which was the birth of mobile augmented reality. Early augmented reality experiences started getting created, where users could overlay digital information onto physical environments. Number of application use cases started emerging, such as in tourism, interactive museum guides, where people could use a smartphone to move around a museum without having to use a physical map, and location aware information systems, which told people about where they are, and according to where they could get feedback on what to do next or where to go next. So, new possibilities emerged with the development of mobile AR in the real world context in terms of mobility and in terms of everyday accessibility of our real world. Unlike earlier augmented reality systems, smartphones placed augmented reality into the hands of millions of users. Parallelly, there were a number of advances in computer vision, which also helped the development of AR and VR systems. Now, AR depends heavily on computer vision, because you use a camera to sense the world around you and you overlay physical information on top of the real world. There were a number of key breakthroughs that took place in this period after 2010, that included feature detection, where you could identify visual landmarks in images, tracking, where you could determine the camera position in real time and you could use that information to overlay content, and a technology known as SLAM. So, SLAM stands for simultaneous localization and mapping. It allows us devices to understand surroundings, build 3D maps and anchor virtual objects. This typically consists of using a LiDAR or a camera to get a point cloud or a 3D image of the world around you and localize yourself and position yourself on a map. Modern AR would not exist with this development in SLAM technology. So, all of this led to the development of what can be said to be the first real VR headset in the 2000s, which is the Oculus Rift headset. This was developed by Palmer and it was launched in 2012. So, Palmer Luckey launched this Oculus Rift Kickstarter campaign in 2012, which can be said to be a turning point in the fortunes of AR VR. It generated a lot of excitement worldwide, as the headset was extremely affordable. It had much improved displays than the earlier headsets of the 90s. It had high quality motion tracking, and the latency between the user movements and the refresh of the display screens in the VR headsets was much lower. So, this campaign which Palmer Luckey launched in terms of the Oculus headset, which you can see on the right with its two controllers for the two hands, it demonstrated a lot of interest in the public in immersive experiences. So, people were really excited to get this experience from this new headset. So, Oculus succeeded due to a number of reasons. There were a number of technological factors behind the success in terms of better displays, faster GPUs, reduced latency and improved tracking. So, smartphone screens became inexpensive and high resolution, and that contributed to the development of these displays, which were really good to look at and gave you much greater immersion than older headsets. GPUs became faster due to gaming hardware, which could render immersive environments. Motion to photon delays were reduced significantly, as well as there was natural tracking of head movements, which felt as if you were making movements in the real world, and the headsets were in general much more responsive than previous generation headsets. So, as a result, users experienced a stronger sense of presence than previous VR systems. Subsequently, 2 years later in 2014, Facebook acquired Oculus for approximately $2 billion. Now, that signaled a great confidence that the industry had in this technology, and it also signaled a major investment in this technology and a long term commitment to the development of AR VR systems. This acquisition really accelerated the development across the entire XR ecosystem. Now, slowly by slowly, a number of competing technologies started emerging. Now, the consumer VR ecosystem consisted of not only the Quest headset, which was from Facebook, essentially the next generation of the Oculus Rift, which was a standalone wireless VR headset, but also there were competing headsets by HTC, the HTC Vive, which gave you VR on the scale of a room, and also PlayStation VR, which was more focused on gaming. So, gaming focused immersion. The impact of all of this was that the competition accelerated innovation and reduced the costs of AR VR technology. Slowly AR took off as well. So, in parallel with the VR developments, there were developments in AR. Three top developments include the Google Glass, the Microsoft HoloLens and the Magic Leap. The Google Glass focused on wearable information access. However, it had some challenges in terms of privacy concerns and limited functionality. You can see one of the users wearing one of these headsets. Then the Microsoft HoloLens came around, which was more focused on industrial and enterprise applications. So, it could be used on factory shop floors, for instance. Another key AR headset that came around was the Magic Leap. It introduced a number of advanced spatial computing concepts. So, you can see here some of these AR headsets that came around in parallel with the developments of VR. Let us take a closer look at what HoloLens in particular helped us do. HoloLens ushered in what is known as mixed reality, where AR was able to overlay information and MR was able to integrate the virtual objects into physical spaces. So, the virtual objects could be actually integrated into physical spaces, as you can see in the depiction on the right, where a machine needs to be repaired and you can see the overlaid content. Okay, there is a physical machine and equally on top of that there is the overlaid content that the user can see once he sees through his headset. So, this led to a number of applications such as virtual machine instructions, interactive engineering models and the ability to carry out design reviews collaboratively as a team. So, virtual objects could appear fixed in real world environments and that was quite helpful, because you could have a team that is working together on a particular setup and they can also see this overlaid content, which is helping explain their ideas or helping troubleshoot. In 2016, there was another leap in terms of gaming app known as Pokémon Go. So, this gaming app was essentially an augmented reality app which was released in 2016 and it involved discovering, catching, training and battling virtual Pokémons in the real world while interacting with real world locations and other players. You can see a depiction of that here, where you can see there is a Pokémon on top of a real world environment on a terrace. And on the right you can see an app with a map. So, where the Pokémons are shown overlaid on top of the map. So, the user needed to go to these locations to catch these Pokémons or train them or battle with them. So, this was quite entertaining for people all over the world and millions adopted this app. It was based on location based gameplay. It used familiar intellectual property, it had social interaction enabled in it and it was quite accessible because you could download it from Play Store and other app stores. So, this had profound impact in the progress of AR VR technologies. More than any system, Pokémon Go introduced AR to mainstream audiences and made augmented reality popular. So, XR kept rising and slowly people started feeling a need for a new term to capture the various types of extended reality. The boundaries between AR, MR and VR also started blurring in this time and XR became an umbrella term encompassing augmented reality, mixed reality and virtual reality. The industry gradually shifted its focus from individual technologies to immersive experiences as a result. Parallel to the development of extended reality was the ushering in of the fourth industrial revolution or what is known as industry 4.0. Here people were looking at manufacturing applications where there was need for training workers, there was need for preventive maintenance, there was need for remote assistance and digital twins were being created. In all of these applications, AR and VR technology started playing a key role. By using AR VR technologies, workers could learn procedures safely. For instance, if you had a worker who had to be trained on an industrial robot and if you could create an app which could then sense the buttons and the controls of the industrial robot and tell a worker which button to press and what instruction to load, in sequence so that a certain manufacturing operation can be carried out, then the worker could learn the procedure in a safe manner and in a manner in which the actions of the workers were also being tracked, and he was getting feedback based on what he was doing. During this period, AR/VR technologies also helped people maintain machines. So, if you had a machine that had broken down and you wanted to figure out where specifically you need to intervene to carry out maintenance, an augmented reality overlay on top of the machine could tell you which specific parts to remove and what to do next in what sequence on top of the real machine. So, that was quite helpful instead of having to repair the machine from some physical paper manuals. These technologies also enabled remote assistance. So, you could be guided remotely, and that reduced the need for bringing in expert workers to carry out, for instance, maintenance. So, experts could assist workers remotely. Likewise, digital twins, which were virtual replicas of physical assets, could now be created and loaded onto AR and VR headsets, where you could put on the headset and immerse yourself and understand what the machine is up to now, even if you are located somewhere else. So, XR became a productivity tool more than just an entertainment technology in this phase. We will now look at specific sectors where XR started making impact. One of the key sectors where XR started becoming used frequently was healthcare. Specifically in healthcare, XR was used for medical training, surgical planning, rehabilitation, and also improving people's mental health. So, by creating an immersive medical training environment, virtual reality apps could help trainee doctors and trainee nurses get a safe practice environment where they did not necessarily have to involve themselves with live cadavers where they could get infected themselves, for instance. XR also helped in planning surgeries by overlaying content on top of human bodies and also visualizing the anatomy of individuals. XR was increasingly used for rehabilitating people. So, people could get rehabilitation exercises which they could train on remotely without having to travel to specific locations, and this enabled patient recovery support. Equally, it helped with the mental health of people by providing them exposure therapy and treatment, and so it helped people overcome the difficulties that they were facing in maintaining their mental health. Slowly, these interventions made healthcare one of the fastest growing XR sectors. Likewise, XR had an impact in education, where traditional learning needed textbooks, lectures and videos. Now, you could afford to learn immersively in 3D. Virtual labs started getting created. You could create simulations of history and learn history interactively, and you could take interactive field trips without having to go to various locations, thereby saving time and also learning in a manner where you could ask questions and interactively learn in an immersive environment. So, this enabled learning by experiencing rather than only observing, which accelerated the way people learn. All of these developments have given rise to what is now known as the metaverse. Metaverse is a term similar to the universe, where instead of living in the physical universe, we go into the digital world and traverse our journey through an equivalent of the universe, which is the metaverse. So, the metaverse can be said to be a persistent digital environment where people can work, learn, play and socialize, similar to the real world. Now, some key questions do remain as we move into this journey in the metaverse. The first question is, well, this metaverse, is it really feasible in all realms of life or only in certain realms? How technically feasible is it? Will users adopt it in the long run and discard the real world, or have a hybrid of the real world and the metaverse? What business models will emerge that will take advantage of the metaverse? So, all of these are interesting questions to ponder about as we make our journey through the metaverse. The concept is both promising and controversial as we slowly take our footsteps into the metaverse. We talked briefly about the digital twins. Digital twins are nothing but a digital representation of a real world system. They go a step beyond the simulation of the third industrial revolution. So, not only we can simulate the real world, but also we can have an accurate capture of the real world that is shown on a digital screen. So, let us say a tool on a machine has worn out, we should be able to see it in the digital representation as well. So, that is what is known as a twin of a physical system or a digital twin. Now, digital twins have become really popular in factories, smart factories, in hospitals, in aircraft engines, and even entire cities are being twinned. They are important because they combine Internet of Things, where all of the things are getting connected to the internet. They also include the effect of the emergent artificial intelligence wave, and they also combine XR. So, digital twins combine all these three emergent technologies, and XR plays a key role in the digital twin journey. Digital twins are increasingly being used for decision support, such as preventative maintenance of machines, and in simulation of real world systems. Now, we are moving through an era where there is an AI revolution, and AI is also supporting this progress in XR technology. So, increasingly there is a convergence between AI and XR, where AI is providing intelligent virtual assistants who can process the natural language that people speak. It is helping create digital humans which can serve as avatars or representations for you in the extended reality world. It is also helping create adaptive learning environments which are getting interwoven into XR technologies, and it is helping create automated content which can also be used in this virtual reality and augmented reality apps. So, AI is indeed helping in this journey. One example of this is where, for instance, you create a smart robo patient. So, virtual patients are often used in clinical practice, but if these virtual patients which are present as apps which are loaded into VR headsets need to be updated with the latest advances in medical science or latest case studies of various patients undergoing treatment, then we need to invest a lot of human time in processing what is happening in the real world. But with AI, this processing can occur with the help of analyzing the natural language from videos, with the help of analyzing for instance, the prescriptions given by doctors and integrating them into the virtual patients app. So, indeed AI has given us a lot of future potential. AI may dramatically reduce the cost of creating these immersive experiences in the future. So, something to think about where XR is heading in the future. Also, parallelly there has been an explosion in spatial computing development. So, we are moving beyond screens now, and computing is also moving into the physical space around us, where computing is context aware. It is aware of the context in which the computation needs to take place. It is anchored spatially to the world around us. It is multimodal, where it is capturing data from multiple modes. So, not just visual, but also audio, but also touch. So, all different modes of perception, and it is increasingly interactive. So, in this new spatial computing regime, digital objects behave as if they exist in the physical world. So, there is a merging of the physical and the digital worlds thanks to the emergence of spatial computing. A key example in which spatial computing is being used is that of the Apple Vision Pro headset. Apple has introduced XR as spatial computing rather than simply VR. So, increasing the innovations in form of high resolution displays, eye tracking, hand tracking and seamless AR/VR blending that are demonstrated on this headset. So, a display in the Apple Vision Pro is of a high resolution, there is eye tracking, there is hand tracking as well as a seamless blending of augmented reality and virtual reality within the headset. Now, this kind of an innovative headset may also influence the future interface designs that occur. So, if we see the evolution of how the interaction between humans and computers has been evolving, we see that from the command lines of the 1980s, we slowly moved into desktop GUIs of the 90s. Then we had mobile computing emerge in the late to 2010 period, which gave way to touch interfaces and then voice interfaces, and finally, now we are in an era of spatial computing since the 2020s. The key insight is that every major shift has changed how humans interact with information. However, a number of current challenges remain. These include technical, human factors and content challenges. Technical challenges include battery limitations. So, these headsets usually will be powered by a battery which may offer you 2, 3, 4 hours of continued work without getting recharged. The cost of the hardware still is fairly high, of the similar order as smartphones. There are also constraints in terms of the field of view that these AR VR headsets of today can capture. Headsets still cause motion sickness despite the increase despite the reduction in latency. They may still lead to cognitive overload, and there are still accessibility challenges for using headsets across the entire population. Content development is complex, it is not easy, it requires a lot of thinking and a lot of clever storyboarding to create new content for AR VR. And so, as a result, the high quality content in the 3D AR VR domain is limited. Several ethical questions also remain, such as privacy concerns, because the sensors in digital twins for instance may remain on all the time. The concerns regarding surveillance, as there is continuous capture of the environment around you. There are concerns also around whether people may be manipulated by these XR technologies and be drawn into persuasive virtual experiences which they may not have been interested in the first place, and the psychosocial impacts of those. The concerns around the equity that XR brings in terms of who benefits from these technologies, who really benefits, is it the big companies, big corporates, or is it the public at large. So, designers must address these issues proactively. The emerging trends are in terms of AI generated worlds, creation of digital humans and avatars, advanced haptics and wearable XR in the near future, and in long term we are looking at even brain computer interfaces, persistent virtual worlds and increasing human and AI collaboration. Let us look at a new development in recent times that will help us understand where the technologies are headed. This is known as the AIRR tablet. It is from the Ishikawa Group Laboratory in Japan. It is essentially a floating display with high speed gesture user interface. So, let us have a look. So, as you will see in this video, what has been attempted is a floating display, where gradually we will move away from screens and will start thinking about a paradigm where we can compute in the air, for instance. So, there is nothing over the table and the user touches and some button emerges. So, and the user can use his touch and his finger movements to actually move objects, digital objects. So, this demonstrates the capability of interacting in a high speed manner. You can punch the screen and the screen will not be damaged, because all you are doing is you are interacting with a floating display which is literally in air. So, real image is formed in the air, as you can see in this video, and that is what helps you interact rather than a display which you need to wear around your head. So, you can see where these technologies are headed now. So, to summarize the XR timeline, in 2007 the smartphone era started. 2012 Oculus Rift was introduced to the world. Oculus was acquired by Meta in 2014. HoloLens came around in 2015. The app Pokémon Go came around in 2016 and became the first massively popular augmented reality app. Digital twins started expanding in the 2020s, and 2024 onwards spatial computing has started becoming mainstream. From a design perspective, technology changes rapidly, but human needs change slowly. So, we need to keep pace with technology now, and as human needs change slowly, there is a core design question that needs to be answered. How can these immersive technologies improve the learning in our day to day lives, in our educational systems, in our schools, colleges, universities, etc.? How can we use these immersive technologies in the domain of healthcare, for instance? How can we improve collaboration between humans by using these immersive technologies? and how can we improve the quality of life of the general public using these immersive technology. These are interesting questions which you all need to think about, and you want to be thinking about as we move through this course, how you can apply these technologies in your day to day jobs, in your future projects, and so on and so forth. To summarize what we learned today, smartphones enabled the XR revival. AR, VR and MR, augmented reality, virtual reality and mixed reality are converging. XR has moved beyond entertainment into real world applications in various domains such as manufacturing, healthcare, aerospace and so on and so forth. Spatial computing indeed may become the next major computing paradigm. In all of this, human centered design remains critical. Looking ahead, we will next cover an overview of AR, VR, XR systems. We will talk about things such as XR system architecture, we will go into depth regarding displays, sensors, tracking technologies and rendering pipelines. So, before the next class I have this discussion question. Well, you may want to identify 5 trends in AR, VR research and post on the forum for the lecture with any relevant citations and links. You may want to think about, well, what trend attracts you the most? I showed you many different trends. What contribution would you like to make to this field? Alternately, how would you like to use your knowledge of AR, VR? I thank you for your attention and I look forward to seeing you in the next lecture.